This video is lesson 2.1. It's about radicals and rational exponents. Now, before we can start, we need to talk about the vocabulary that's used here. First of all, the word radical is in reference to our square root symbol. So the radical symbol is this little division symbol with the check mark in the beginning, and it's used to indicate square roots. Now, we have other roots, cubed roots, fourth roots, etc., and we use a radical symbol, but we put a number inside that little hook right there. So it's still a root, but instead of being the square root, it could be the cubed root or the fourth root or the fifth root, depending on what number is in that little hook. Now that number in that hook, we call it the index, and the number inside the radical, we call the radicand. So when I use those words later, you'll know what they mean. We're also going to be talking about rational exponents, and this word right here, ratio, which is the base for rational, tells us that we're going to be using division because ratios involve division. So we're going to talk about how radicals and rational exponents are related. Now, here in our first example, we have the square root of 4 equals 4 to the k power. What we're trying to figure out here is how are this radical, this square root symbol, and the exponent on this 4 related? What is the relationship between that radical and that exponent? So in order to figure this out, we are going to square both sides. And the purpose of squaring both sides is to get rid of this radical now, because the square root and the square basically cancel each other out. When we do this, we need to remember this rule of exponents right here. When we have a base to a power inside parentheses and then another exponent outside the parentheses, we have to multiply those two. So say I had 2 to the third power and then it was squared on the outside of the parentheses, that would be the same as 2 to the 3 times 2 power, which is 2 to the 6th. So when you have exponents inside and outside parentheses, you multiply them. Now, I'm going to square both sides here, so I've got the square root of 4 and 4k, and I'm squaring both of them. 4 to the k power. And I'm squaring both of those things. Now, here my square root and my square undo each other. This says, what do I need to square to get 4? Well, it's 2, and then I'm going to square it and get 4 to the first power. So the square root and the square cancel each other out, and I'm just left with 4 to the first power. Here I have 4 to the k power, and then I'm squaring it. So in that case, I'm going to multiply those two exponents. K times 2 is 2k. So I have 4 to the first power equals 4 to the 2k power. Now this rule right here tells me that if I have the same base on both sides of the equal sign, then that means my exponents have to be equal also. So 4 to the first power equals 4 to the 2k power means that 1, my power on this side, has to be equal to 2k, which is my power on the right side there. So 1 equals 2k. Now I have a really nice equation that I can solve for k. So if I want to get k by itself here, I know that I have to divide both sides by 2. Those cancel. I'm left with k on the right side and 1/2 on the left side. So since I know k equals 1/2, the square root of 4 equals 4 to the 1/2 power. Now, that was all a little confusing, but here's what it means, and I'm going to use the next example to show you what it means. It means that whenever I have a number in a radical, so here I have the cubed root of 8, I can translate that into an exponent by looking at the power of the number under the radical and by looking at the root. Now, this is 8 to the first power. The power is our numerator in our exponent. And the root is the denominator in our exponent. So I still use my same base, which is 8. And then it's to a rational power where my numerator is 1 and my denominator is 3. So the cubed root of 8 to the first power is 8 to the 1 over 3. Notice this top number is my exponent, and this bottom number is the root, or the index that I'm taking. Now, if you wanted a further example, you might look at, let's see, the fourth root of 2 to the third power. Now I'm not going to work this out, but I am going to show you how to translate it into a rational exponent. Now I'm going to use my same base, so still 2. The power that I'm taking that base to, in this case is 3, is going to be the numerator in my fractional exponent, and the root that I'm taking right here is going to be the denominator. So this would be the same as 2 to the 3 over 4 power. Now our reflect question here says, how can you write the square root or cubed root of a number using a number n using an exponent? So you're going to write a fractional exponent, or an exponent that's a fraction, with the power on top and the root on bottom. Just like up here, power over root, 1 over 3. All right, so here we have some general rules of simplifying expressions with rational exponents. So a number raised to the power of 1 over n is equal to the nth root of that number. Now that's a little confusing, but here are some examples to clarify it. B to the 1/2 power is b to the first power, and we're taking the second root, or just the square root. So 25 to the 1/2 power would be 25 to the first power, and we're taking the square root, or second root. 8 to the 1/3 power would be 8 to the first power, and we're taking the cubed root. Again, top number is the exponent, bottom number is the root. And 81 to the 1/4 power would be 81 to the first power, top number is the power, and then we're taking the fourth root, so square root, or I'm sorry, radical symbol with the 4 inside. Now, what each of these mean? Square root means what do I square to get this number? Cubed root means what do I cube to get this number? And fourth root means what do I take to the 4th power to get this number? And in order to get those answers, we're going to have to do some factoring. So in example 1 here, we want to simplify each expression. Now, 64 to the 1/3 power, our top number, 1, is going to be our exponent, and our bottom number, 3, is going to be our root. Now, we can translate that into a radical by saying, okay, we're taking the third root, because that's the bottom number, and then we're taking it to the first power. And we're wanting to know, what do we cube to get 64, or what do we multiply by itself 3 times to get 64? Well, 64 is 4 times 16, and 16 is 4 times 4. So I can rewrite 64 as 4 to the 3rd power. Now this question is asking me, what do I take to the 3rd power to get 4 to the 3rd power? And that sounds like a trick, but it's really not. In order to get 4 to the 3rd power, what I had to take to the 3rd power was 4. So the cubed root of 64 is 4. In part B here, we have a problem that involves exponents and subtraction. And we know that we want to do exponents before subtraction because that is what it tells us to do in the order of operations. So the first thing I'm going to do is translate these into radicals. Remember, my bottom number is the root that I'm taking, and the top number is the power. These are both to the first power, but I'm taking different roots. I want the 5th root of 32 minus the square root of 81. When it's a 2 on the bottom, you don't have to write the 2. So once these are translated into radical form, 5th root of 32 minus the square root of 81, I can start to simplify them. Now, I need to know, what do I take to the 5th power to get 32? So if I were to factor 32, I'd find that it's 2 times 16, and 16 is 2 times 8, and 8 is 2 times 4, and 4 is 2 times 2. So I can rewrite 32 as 2 to the 5th power. Now, what do I take to the 5th power to get 2 to the 5th power? Well, 2. Also, I can simplify the square root of 81. That's when you should know that the square root of 81 is 9. So I have 2 minus 9, and when I simplify that, I get -7. In reflect question 2 here, it says, is b to the 1 over n, where b is greater than 0 and n is a positive integer, always a positive integer? Justify your answer with reasoning or a counterexample. What they're asking here is, if you take the root of a number, the second root, the the cubed root, the fourth root, the fifth root, etc., will you always get a positive example? Now, I will tell you that the reason, or that you will not always get a positive answer. And the reason for this is that sometimes negative numbers pop up in your radicand. For example, if I'm finding the cubed root of -8, I want to know what number did I multiply 3 times to get -8. And since if I multiply a positive number 3 times, I will get a positive number, the answer to this problem must be negative. And what do we multiply 3 times to get positive 8? We multiply 2 3 times to get positive 8. So what would we multiply 3 times to get -8? Well, we'd multiply -2 3 times. So this is our counterexample, and our answer is no. It can be negative sometimes. Now that's only true when you have an odd root. You can only take an odd root of a negative number. Here's a little bit of review. This is using the properties of rational exponents. So we can use these properties with exponents that are fractions and exponents that are not fractions. They work both ways. So the first one is the product of powers property. A to the m power times a to the n power equals a to the m plus n. It basically just says that when you're multiplying like bases, you add their exponents. So like here we've got 2 squared times 2 to the third. We're multiplying these and they have the same base, so we add their exponents. 2 plus 2, or 2 plus 3 is 5, so it's the same as 2 to the 5th power. Then we have the quotient of power properties. And that one basically says that if you're dividing like bases, you subtract their exponents. So here we have 2 to the 5th divided by 2 to the 3rd. Our bases, the 2's, are the same, and we can subtract their exponents. 5 minus 3 is 2, so it's the same as 2 squared. The next one is the power of a product property. That's the one we talked about. Oh no, when we're multiplying two things in parentheses, we basically have to distribute our exponent to both of those things that we're multiplying. So in this example, inside the parentheses we have 2 times 3, and then we're squaring it, which means we have to square everything in the parentheses. So we square the 2 and we square the 3, and then we multiply them. Then there's the power of a quotient property. It's the same as the power of a product property, except it involves division. So when we're dividing two numbers inside parentheses and there's a power on the outside, that power still has to be distributed to both parts of the fraction. So if we're squaring 1/2, we have to square the 1 and square the 2. We have to square both parts of the fraction. Then we have power of a power property. That's the one we talked about before, where you have exponents inside and outside the parentheses and you multiply them. So 2 squared and then squared again would be 2 to the 2 times 2 power, or 2 to the 4th. Finally, we have the negative exponent property, and that's the one that says that if you have a negative exponent, you can move it to the other side of the fraction bar to make the exponent positive. So 2 to the negative 2 power is the same as 1 over 2 to the positive 2 power. We've moved this whole term down into the denominator to change it into a positive power, because we can't actually take negative powers of things. Now, here we have a few examples. Example A is 125 to the 2/3 power. Now, remember before that I said the top number is the exponent and the bottom number is the root. So I know I'm taking the cubed root of 125. And then I'm going to take it to this power, the second. So I'm going to square it. So I'm looking for what number did I cube to get 125. If I factor 125, I find that it's 5 times 25, and if I factor 25, that's 5 times 5. So I can rewrite 125 as 5 cubed, and that's what they've done here. They simplify inside their parentheses. Sorry about that focus there, guys. Oof, what a mess. They simplify inside their parentheses, so the cubed root of 125, or the cubed root of 5 cubed, is 5, and then they square it. So 125 to the 2/3 power would be 25.